Okay. So in the last class, we have discussed the concept of partition views, stored procedures, and user-defined functions. Okay. So let's move towards the next concept. Once again, guys. Yes. Next, let's move towards the next concept, that is transactions. Why do you need a transaction? So basically, for example, there are two operations in your stored procedure. Operation 1 and operation 2. Let us assume that now you are going to withdraw your money from ATM. The withdraw operation contains two steps, step 1 and step 2. Step 1, step 2. As part of step 1, your account verification will be done and your amount will be deducted from your account. As part of step 2, whatever is deducted from your account will be deposited into beneficiary account. Okay, let us assume that we are doing some online transaction. Let us assume that we are doing some online transaction. Okay, or you can also take ATM. In online transaction, what you will do, you will add beneficiary. Whenever you click on, whenever you enter your all card details and click on proceed, what it will do, first it will deduct your money from your account. That will be done as part of step 1. And step 2, whatever is deducted from your account, it will be deposited into respective beneficiary account. Okay. In case of ATM, let's say we have inserted our ATM card into ATM. As part of step 1, your account verification will be done and amount will be deducted. As part of step 2, it will dispense your amount. So you have to collect your cash. It will dispense your amount, right? So let us assume that step 1 has completed successfully. Our amount got deducted. But now we came to step 2. While performing step 2 operation, some error occurred. So due to that, your amount was not dispensed or the amount was not created into beneficiary account. Now what happens? In this case, whoever is doing the transfer, if he lose his money, right? Technically, amount got deducted from his account, but did not created into the respective beneficiary account. This operation got succeeded. This operation got failed. Due to this failure, amount was not created into beneficiary account. Right? You will see these kind of cases in many scenarios, right? Many times you might have come across these kind of scenarios. Let's say if you're purchasing something online, you selected the product and went to the payment page. you entered your card details, amount got deducted, but operation got failed in the middle. Right? Now you never know whether your product is going to come or not. The status will still show like it's pending. Recently, it was happened with me also. While I'm doing the LIC payment for my policy, amount got deducted from payment gateway from my account. Amount got deducted from my account through payment gateway, but it was not credited into beneficiary account. Right? In many cases, you will see these kind of scenarios. That leads to a problem. So in this case, what has to be done? If you are going to perform any operation, failure of something should not impact anything. In case of ATM also, especially if you go to government bank ATMs like SBI, or not private bank ATMs also, any ATM, not only government or private, you can go to any ATM. Many times, if the network is poor, especially you will see this kind of issues in small towns and villages. If the network is weak, and what happens? You will enter your credentials. After inserting your debit card, you will enter your credentials. It will ask you to enter the amount. Then ask you to enter the password. Then it will deduct amount from your account, but it will not come out. It will not be dispensed from your ATM. So that leads to a problem. So failure of one transaction should not impact another transaction. Here, what has to be done? The amount has to be deducted if and only if all steps are completed successfully. Though the amount has deducted from step 1, if step 2 gets failed, it should be rolled back immediately. Whatever is deducted should be deposited back automatically. Are you with me? So failure of one transaction should not impact another transaction. And failure of this entire operation should not impact anything. Let's say if you're performing 10 different steps, 9 steps are completed successfully. If 10th step gets failed, it should not impact all the 9 steps that we have done. The entire operation has to be rolled back. Everything should be retained back to previous state. So if you want to take that level of implementation, that can be done through only transactions. Only transactions. Why do we need a transaction? If you want to roll back something in case of failure in your code, when you want to roll back something in case of failures, then we need transactions. Are you with me? So we also call it as ACID principles. ACID. Atomicity, consistency, integrity, and durability. Atomicity, consistency, integrity, and durability. So as I said in T1 and T2, atomicity and consistency. Let's say operation 1 got succeeded, 2 got failed. Right? In this case, there will be impact. So you have to ensure that the entire thing is rolled back. Integrity. Failure of one transaction should not impact another transaction. Durability. Whatever the transactions that you are doing in your database should be recorded somewhere. Not only your operation. While I'm doing something, my system got failed. My system got crashed. What happens? You may lose your entire data, not only one operation data. Right? While performing something, if your system gets crashed, what happens? You will lose everything. Whatever is stored in your system, you will lose everything. In this case, what happens? It would impact too many things. You will lose your transaction data. That should not be happening. Failure of your system should not impact anything. How do we achieve this? While you're performing anything, record everything into your transaction file. If your system gets failed, you'll have a chance to roll back everything from your transaction file. So that kind of durability should be there. failure of your system should not impact anything. And you should be in a position to roll back everything back to previous state. Those are called acid principles. So this can be achieved through a concept called transactions. When it comes to transactions, we have 4 commands. Begin transaction, save transaction. It can also have name. Save transaction can also have name. Next, commit transaction, rollback transaction. Okay. For example, as I said, in case of T1 and T2, T1 or operation 1, operation 2, or step 1, step 2. In step 1, we are deducting the amount from the respective candidate account. Step 2 will take care of depositing that amount into beneficiary account. If I write my operations like this, if step 2 gets failed, nothing will be rolled back. You will lose your amount. You don't even know what is happening here. Right me. So to avoid that, so what has to be done? If there can be n number of steps, not only 2 steps. If the failure occurs in any step, the entire process, the entire operation has to be rolled back to previous state. If you want to do that, what I have to do? I have to implement transactions. I mean, first I have to open my transaction. So this has to be placed inside your transaction block. I mean, first open your transaction. Your transaction will start here. Next, as I said, I should record whatever is happening in all these steps should be recorded somewhere within your cache so that you'll have a chance to roll back it. If you do not record whatever is happening here, if you do not record it, how can I roll back it? Whatever I am doing here in step 1 and step 2, that should be tracked somewhere, that should be recorded somewhere. That's why you need save transaction. Save transaction. As I said, I can also give name to save transaction. This is called save points. What is the use of same transaction? So it will begin the transaction. And from here, whatever is happening here in step 1 and step 2, those things will be recorded into the save transaction, the save point. You can do anything, whatever is being performed here as part of step 1 and step 2, that whole thing will be tracked into your save point. If something goes wrong, yes, everything is recorded here. Where amount is deducted or deposited. So whatever you are doing here, everything will be tracked into the save point. If any failure occurs, what happens? Here you will have a chance to roll back it from your transaction, your save point. And name is optional. If you want, you can give, otherwise by default, some system name will be created internally. Right? Now I open the transaction, I put a save point. Now if I do anything, it will be clearly tracked into this save point. Now step 1 has completed successfully, step 2 has completed successfully. Right? If everything, if both the steps get completed successfully, now what has to be done? The transaction has to be committed. So keep commit transaction. What commit will do? It will update the changes permanently. Once it is committed, you cannot roll back it. Once the transaction is committed, you cannot roll back everything. Read me. So when should I commit it? If all steps are completed successfully, then I should commit it. When should I roll back? I need to know whether error occurs in my block or not. Right? Whether error occurred in my block or not, I need to know. How do I know it? So this entire operation should be placed inside your try block. Begin try, end to try. Why am I keeping it in try block? Whenever any error occurs in the try block, immediately it will go to catch a block. From where should I roll back it? I need to know, right? whether error occurred in my code or not. If everything gets succeeded, it will commit the transaction. But when should I roll back it? If any error occurs in my code, this is my operation. Now I place the entire thing inside try. If any error occurs in the try black, immediately it will go to cache. It came to cache means is something happened in try. Now here you have to roll back your transaction. If the control comes to cache, when it will go to cache? If any error occurs, then only it will go to cache. Otherwise, it will never go to cache block. It came to cache means, yes, something happened in the try. Now I should roll back my transaction. Are you following me, guys?
Yes, sir.
Okay. Now, let's write a stored procedure. Okay. Create pros. For example, we are updating employee. Okay. SP update employee. EMP-ID int EMP name. You can take anything. Where care of 100. As if you want, you can keep begin and end also for your stored procedures. Begin, end. It is optional. Now, what should I do? This is optional. If you want, you can keep, otherwise you can remove it. So now what should I do? Now I have to write everything inside a try black. First, what is your action? Updating your employee table. In case of your online transfer, what system will do? It will update your table, right? It will deduct something from your account and update your table. So when should I use transactions? When there is a risk. When there is a risk, then you should make use of transactions. So mostly the risk will be there whenever you update something or delete something. If I'm updating something, yes, risk will be there. If I'm deleting something, the risk will be there, because once it gets updated or deleted, it cannot be rolled back. If you are going to insert something, there will be no risk. Though some unwanted data is inserted, you can delete it explicitly. But if something gets overridden, you cannot roll back it. So transactions are more useful when you are updating something or deleting something. Okay. Right. So how do I do this? Let's say update employee set EMP name is equal to EMP name supplied from the calling environment. Where employee ID is equal to employee ID supplied from the calling environment. Right? I can do like this. I can do like this. But what happens if any failure occurs while performing your update operations? You cannot roll back your data. If you want this to be rolled back in case of failure, what has to be done? Your action has to be placed inside the transaction. It means you have to open a transaction block. You have to put a save point. You have to commit it explicitly. If something goes back, if something goes wrong, you have to roll back it explicitly. So in order to implement my transactions, you need to know from where can I roll back it? Where can I commit it? Right to me. So in order to perform your transactions, in order to open the transaction block, put your save point and roll back it in case of failures, what has to be done? So you have to implement try and catch a black, because that exception has to be handled properly. When should I roll back it? In case of exception, in case of failure. Whenever any exception is occurred in my code, that leads to a failure. So whenever any exception is occurred in my code, then I need to roll back the transaction, the entire transaction. Are you to me? So that's why here you have to implement try and catch blacks. Begin try, end try. Begin catch, and catch, right? Why I'm keeping try and catch? So if you keep your entire operation inside try, if everything gets completed successfully, then it will never go to catch a black. It will go to catch a black if and only if any failure occurs in your code, any exception occurs in your code, any error occurs in your code. So while performing this operation, here I have written only one line of code. But when it comes to banking application, you will be writing 1,000 lines of code. So keep your entire operation inside a try black. When control comes to a try black, it will start executing all the lines one by one. If exception occurs at any line, immediately it will go to catch a black. It came to catch a means, yes, something went wrong with your code. It means some exception has occurred in your code. Now what should I do? I should roll back it, right? So if you want to roll back it, first you have to open a transaction black. How do I do this? Begin transaction. Next, I should keep a save point. Save transaction. Okay. You can also give a name. So one save point will be created with the name S1. Otherwise, by default, it will be created by the system. Next, once this operation gets succeeded, once my code executed succeeded, then what I have to do? I should keep commit. Or you can also give it as commit transaction. Next, if something goes wrong here, if any exception occurs while updating the employee table, immediately it will go to catch a black. Right? If that comes to catch a, what has to be done? You have to roll back your transaction. Roll back transaction. Ready me. Now execute it. Now my SP has created. Any questions, guys?
No, sir.
Okay, so this is something about your transactions. Okay. So wherever you are performing update and delete operations, there you may need to make use of transactions. If it is a simple update or simple delete, transactions are not required. But if you are going to perform some complex operations, if you feel like the impact may be very high, then better make use of transactions. I don't know, for example, especially when it comes to financial related operations, when it comes to banking applications, share market applications, some online finance applications, right? There you'll be dealing with money. If something goes wrong with it, that leads to many issues. That's why if you are playing any operation with money, better make use of transactions, because system failure may occur at any time, right? Due to so many reasons. If your network is down, that would also impact your operation, execution of your operation. Let's say my system has started executing something. While it is executing, the network went down. Now what happens? That leads to a failure. So failure can come in any direction, in any way. So that's why we should be ready to face that. Okay, so especially if you are going to deal with financial operations, especially if you're updating something and deleting something, to be on the safer side, make use of transactions so that you will have a chance to roll back your data. Now what it will do, I don't have to roll back it manually. Whenever any exception occurs, immediately it will go to catch a, the entire operation will be rolled back. It will be reset to previous state. Let's say as part of operation 1, my money got deducted. When it comes to operation 2 got failed. Now what happens? If any exception occurs in operation 2, immediately it will go to catch a black. Here it will roll back the entire transaction. It means again your money will be added back to your account. That is what happening nowadays. Though your money is deducted, but still you are getting it back, right? How come? Because they're making use of transactions. What transaction will do? Transaction would record each and everything into a file. whatever you are doing here as part of your operation, everything will get recorded into one of the transaction file. That's why if something goes wrong, it will restore everything back from that transaction file. Any questions, guys?
No, sir.
Okay. In the old days, when this online system was started in the beginning, right? They used to update and delete directly without any transactions. That time, no, like if you face this kind of issue, okay, like let's say your money is deducted from your account, but it's not credited into beneficiary account. We used to go to banks, they used to check it manually, they used to contact the teams manually. Or there was some kind of manual process to get it back to your account. It used to take months and months also. Nowadays, it is not like that, right? If something gets deducted, if the transaction is not successful, immediately it will be, like roll back just because of your transactions concepts. Okay. Any questions, guys?
No.
You may or may not see transactions in all stored procedures when you join a real-time application. But if it is a financial based application, definitely you will see transactions in many places, in many stored procedures. Okay. When you feel like there is a risk, 1 second, please. Sorry guys, I got a call. Okay, so any questions about transactions?
No, sir.
Okay. If no, let's move towards the next concept. Triggers. Trigger. So why do we need a trigger? For example, when it comes to stored procedure, right? We have created a stored procedure called save employee data. Right? Inside this stored procedure, you can write your operation. You can write your action. Right? Every stored procedure, a stored procedure is nothing but a subprogram. It will take care of performing an action. So inside your stored procedure, you can write an action. Whenever I want to execute this action, what has to be done? For example, let's say you've written something inside your subprogram. If you want to execute that action, that subprogram, what has to be done? This has to be called explicitly from your calling environment. If I do not call this, will it be executed automatically? No. Will it be executed automatically? No. It has to be called explicitly from the calling environment. If you do not call it, it will not be executed. Are you with me? So this action will not be executed automatically. Okay. We have implemented some constraints on our table. Let's say primary key and foreign key, right? Not null, check. We have implemented some constraints. What is the use of primary key? Primary key will also take care of performing one action. What is that action? Whenever any record comes for insertion or updation, whenever any new record comes, it will check whether that particular value is a duplicate one or not, whether it is not null or not. What is the nature of primary key? It will take care of ensuring the value is not null and it is not a duplicate value. That is the responsibility of primary key. Are we calling this primary key explicitly to perform that operation, or is it getting automatically whenever the new insertion comes to the table? Guys, Ran, you have to answer. Whenever you insert a new record into your table, are you calling primary key every time explicitly?
No,
No, sir.
we will just assign it once.
Right?
Yeah.
We just assigned it once, but every time this is getting executed automatically. Whenever that situation arises, whenever any new instruction comes to the table, it will be triggered automatically and it will take care of ensuring the value is not null and it is unique. And when it comes to foreign key, we will set it during your object creation only once. It will just keep on watching the things. Whenever the situation arises, for example, you are going to insert a department ID, whenever any new record comes, the responsibility of this is to ensure that the value exists in the master table. Every time, so wherever you have placed this, it will take care of watching that particular field data. And not null. It will have its own responsibility. It will ensure that the value is not null. So while inserting a new record into your table, are we calling these actions explicitly? No. If it is a stored procedure, if you do not call a stored procedure, it will not be executed. Stored procedure has to be called explicitly from the calling environment. Primary key is also one of the subprogram, but it is a system subprogram. Subprogram, what is subprogram? Kind of action. Every subprogram will take care of performing a specific action. Alright, if you write add will take care of adding numbers. Multiplication will take multiplying numbers. That is the action. Every subprogram will have its own responsibility, will take care of performing a specific action. Now, when it comes to primary key, this is also kind of a subprogram. This has been created by the system. It is a system subprogram. Whenever you need to ensure the value is not null and you're not inserting duplicate values, there you need to keep this action. But when you're inserting records into a table, are we calling primary key explicitly? No. Are we calling foreign key explicitly? No. What is happening? This will be invoked automatically by the system. Whenever that particular situation arises, whenever you try to insert a new record into a table, what it will do? It will be triggered automatically. It will take care of performing its responsibility. It will take care of performing that respective action. Are you with me? So this is also kind of a subprogram, but we are not calling explicitly from the calling environment. This will be triggered automatically by the system. Whenever any new record comes, new insertion comes, it will be invoked automatically without our intention. When some action has to be executed automatically, then we require a concept called trigger. When you talk about primary key is also one of the trigger. Foreign key is also one of the trigger. Not null is also one of the trigger. All your constants are triggers. But is it a trigger? But this will take care of the same responsibility every time. What is the responsibility of this trigger? Every time it will take care of identifying null values and duplicate values. It will take care of ensuring you are not inserting null values and duplicate values. Are you with me? And this trigger is a system trigger. The code and everything has been written by the system. You cannot alter it. For example, if I want to modify this action, I want to add some more things to that existing action. You cannot do that. Like primary key, like foreign key, like not null. If I want to add my own trigger to my table, right? These are predefined actions. Primary key will have predefined action. Foreign key will have predefined action. Not null will have predefined action. They know their responsibilities. These are all static responsibilities. But I want to perform a different action other than this primary key, foreign key, and these things. Whenever the user try to insert some data, I would like to check the transaction amount. Or I'd like to check some other things. I wanted to check some other business rules. Are you with me? So that cannot be possible through these system defined triggers. Primary key is also a trigger. Why do we need a trigger? When some action has to be done automatically on your table, then we require a concept called trigger. Yes, your SQL is providing some system defined triggers. Those are called constraints. These are used to perform, or these are used to validate simple actions, simple business rules. If you want to validate complex business rules, if you want to validate your own business rules, if that has to be validated automatically, if that has to be executed automatically, then your approach should be towards triggers. You have to write your own trigger. That is called user trigger, custom trigger. Are you getting me? If something is provided by system, we call it as system trigger. If something is designed by you, we call it as custom or user. Custom trigger or user trigger. Any questions, guys?
No, sir.
Okay. So now let's check. Okay. Let's see how to design our own trigger like your primary key and foreign key. Right? Whenever some situation happens, some action has to be done automatically. Okay. Let's see. I'm going to create a table called create table transaction or account. Okay. AID, account ID, int identity of 1,1, account name, varchar of 100. Okay. Next, amount, money. Okay. Available amount, and I can say balance. So let's keep it as a transaction table, transactions table. Account ID, account name, balance, and amount requested for withdrawal. Amount requested, money. Okay. Account ID, account name, the balance amount that is available in your account, and whenever you request some amount for your withdrawal, that will also be recorded here. Okay. This is our table. Let us assume that you are holding, when it comes to account types, you will see different types of accounts like saving account, right? And business accounts, NRI account, current account. When it comes to saving account, balance can be 0. For example, if you're having 10 rupees in your account, I requested for 10. Yes, it can be withdrawn. But when it comes to current account, there are some restrictions. You should maintain minimum balance of 10,000 rupees. Let us assume that my balance amount is 10K. I requested for 2K. Now what happens? It has to check every time. Whenever you send a request for withdrawal, it should check the minimum balance. If the balance is greater than the minimum balance to be maintained, then you should be allowed to withdraw money. If it is not that, the transaction should be rejected. Ready me? Okay, so let's do that. Let's create a table got created successfully. Select star from transactions. Yeah. When it comes to transaction, you will find two magic tables: inserted, deleted. These are system tables, temporary system tables. Whenever you insert something, delete something, your data will not be inserted directly into a table. Before inserting it into a table, there will be some checks. First, your data will be inserted into this thing, this temporary table. These are called magic tables. Why are we staging your data? Because here you may be keeping some constraints like primary key, foreign key, and other constraints. But the constraint verification has to be done first before inserting it into your table. That's why whenever you send something, first we will hold it somewhere. Where I will be holding it? By default, it will be inserted into this magic table, inserted. Now your constraints verification will take place. If the validation is successful, then only your data will be inserted from this magic table to your actual table. If I update something, in case of updation, what happens? Your old value will go away and new value will be saved. So here you'll be getting two values, old value and new value. So your old value will get overridden with new value. In case of updation, let's say if you're updating account name, what happens? Your old name will get overridden with new name, right? So technically what happens internally? Your old name will get deleted and new name will be inserted. So in case of update, what it will do? Old name will go to another magic table, deleted, and new name will go to inserted. Ready? Before updating it, what it will do? Copy this old name into deleted, and whatever the name to be updated will go to inserted. So in case of delete, it will maintain both old value and new value. Old value will be there in deleted, new value will be there in inserted. Ready me? So in every database, there will be some magic data tables. Whenever you insert something or update something, it will not be done directly on your table. Rather, first your data will be staged into magic tables. Then, if there are any business rules to be verified before inserting or updating, the constant verification, business rule verification will take place. Once everything goes fine, once the validation is successful, then only the data will be copied from magic tables to your actual table. So this is what will take place in case of insertions and deletions. Any questions, guys?
No.
Okay. Now, if I want to roll back something, If I want to know what user trying to do, what is going to be inserted, I don't need to check my table, because before coming to this table only, I should check. If I keep primary key, when it should check the data or not after inserting, before inserting it into a table only, it has to check everything. So where can I do that? By default, it will go to insert a table and delete a table. So if I want to verify something, I can verify, insert a table and delete a table. If everything looks fine, then I can go ahead and insert it. Okay. So let's try to implement one of the transaction and your transaction table. So go to your database. Where is my database? Customer. Refresh it. Now you should be able to see your table. This is my table. Transactions. Okay. Now there are no triggers, right? Now I'm going to create my first trigger. How do I create the trigger? You have to follow a syntax. What is that? Create. When it comes to trigger, we have two types of triggers. We have two types of triggers. There are two things. Before constant verification, after constant verification. For, after. Here we have two types of triggers. For, after. If I create a for trigger, so what happens? First, it will verify the constants if all business rules are satisfied. Are you to me? So this will be executed for after. This will be executed before constant verification. And this will be executed after constant verification. There is a difference between these two. As I said, first your data will be staged. If there are any constants on your table, constants will come to the picture. It will verify their business rules. Ready me. So that process will always be there if there are any constants on your table. This is again depends upon your requirement. If the trigger has to be executed before the constant verification, if you want your validation should be done first and constant verification next, then go with for. If you want constant verification should be done first, then your validation next, go with after. Ready me. What is the difference for trigger and after trigger? This will be executed before constant verification. So your action will be executed first and constant actions will be executed next. And if you want that has to be executed after constant verification, if your trigger has to be executed after constant verification, you can choose after trigger. Any questions, guys?
No.
Okay.
No, sir.
We have two types of triggers, for and after. This will be executed. That depends upon your requirement. I want something to be validated before constant gets fired. Then go with for. If you want your validation has to be done after constants get fired, then go with after. Okay. Now let's create a trigger. Here syntax as create trigger, trigger name. Let's say DBO dot. You can give any name. Trigger one. You can give any name. My trigger. On which table? This is going to be DBO dot transactions. Create trigger, trigger name. This user defined one. You can give any name. On which table? This trigger has to be created on transactions. And if you have to specify what type of trigger it is, for or after. You have to give this for or after. For what? During insertion or updation or deletion or both. I'm giving it as for insert, comma update. It means I'm saying that so this trigger has to be created and it has to be executed during both insert and update. And you can also give it as delete. Or you can also give only for insert or for update. Are you with me? Okay, you can give anything. Create trigger name on which table for insert or after insert. Are you with me? There is a difference between for and after. How can I turn it into after? Yes, you should use another one. If I use for, this will be executed before constant verification. If I use after, this will be executed after constant verification. Okay. For insert as, now write your code. Now write your code. What is my code? I'm going to give a simple thing. Okay. I'd like to check. Let us assume that this guy balance is 10,000. I'd like to check this amount requested. Amount requested. If the amount requested, let's say we are on year end, we are not allowing transactions more than 10,000. If the amount requested is greater than 10,000, this entire transaction has to be rolled back. Nothing should be updated. The entire transaction has to be rolled back. And we have to give a warning message saying that, hey, you have requested the amount greater than 10,000, which is not allowed. So not only you can write any action based on your requirement. So whenever you try to do something, so what happens? First, data will be inserted into this thing, and data will not be directly inserted into transaction. As I said, there are two magic tables, inserted and updated. First, it will be inserted into magic table, right? So your trigger has to be, this has to be executed before constant verification, right? Now, where will be my data? Your data will be there in the magic table, right? If I want to know how much the user has requested, from where should I take it? You should take it from magic table. How do I do this? Simple. If select amount requested, from where should I take it? Whenever user inserts something, first it will be inserted into inserted table, not this table, right? This is for trigger. It is going to be executed before that row is inserted into a table. Amount requested from where? Inserted. This is a magic table. First, the row will be inserted into this. Here only I'm verifying whether user has amounted, whether the user has requested amount more than 10,000 or less than 10,000. If this is greater than 10,000, if this is greater than 10,000, write to me, begin and end. This if will be very similar to your C# if. In place of braces, we are just keeping begin and end. What has to be done? Just give a print. Sorry, you cannot withdraw more than 10K. You cannot withdraw more than 10K and roll back this transaction. So by default, now you should ask me, like, we did not write to begin transaction and we are directly writing rollback transaction. If you do not open the transaction block explicitly, by default, the transaction block will be opened by your system. That is called implicit transaction. Implicit transaction. Alright, me. By default, the transaction block will be opened, will be committed automatically. Right? If you want to drive it explicitly, you would write your own transaction. Okay. So anyway, by default, the transaction will be opened by the system. You can roll back it. If you do not write this, it will be committed automatically. If I do not write this, what happens? The transaction block will be opened automatically internally. It will be committed automatically. Still, I can roll back it. Are you following me, guys? Any questions?
No, sir.
Okay. Now write this. So my trigger has been created successfully. Here, not only this action, based on your requirement, you can write any kind of action. Okay. Now let's refresh it. Now I can see my trigger. Right? Now what happens? As I said, trigger is like your constant. Whenever, yeah, this is for insert. Whenever any new insertion comes to your table, what happens? You don't have to call it explicitly. It will be triggered automatically, like your primary key, foreign key. What it will do? It will take care of verifying this condition. Whatever is written inside this, it will take care of executing this action. What it is doing, it will check whether amount requested is greater than 10 or not. If it's greater than 10, it will print this message, roll back the transaction. If it's less than 10, then this will be allowed. Okay, so let's see this. Let's try to insert some data. Insert into transactions, values, transaction ID is an identity, AC name, trans one, balance 12,000, and amount requested is 11,000. Right? Now let's try to insert this. We are inserting this into transaction. Now we already created trigger and transaction table that will take care of watching this particular field, amount requested. Okay, let's execute this. Now what happened? See, what it is saying? Sorry, you cannot withdraw more than 10K. The transaction ended in the trigger. Let's see where this is inserted or not. Select star from. Nothing. Right? Now it is working like your constraint. You created your own trigger like constraint. Now if I enter 10,000, it got inserted. Right? Now if I enter 12,000, it got rejected. Right? You're able to throw user-friendly message, your own message. And you took the control over this insertion and you are driving it. You are deciding whether this has to be inserted or not. Right? So when some action has to be designed explicitly, if that has to be executed automatically before inserting or updating. If I want to alter this, you can alter this. And I can keep for insert and update or delete or resume. For insert, update, and delete. I can keep the 3. What happens now? This will keep on watching 3 operations: insertion, updation, and deletion. Any questions, guys?
No.
No, sir.
What happened? Guys, can you hear me?
Yes, sir.
So we can hear you.
Something got signed out. Confused. Okay, so this is something about your triggers. Okay, so these are all advanced concepts: your transactions, triggers, stored procedures, and functions. Okay, I hope now you understood the overall concept of your transactions. When should I go for a transaction? Right? Okay. Next and last concept is going to be temporary tables. Temporary tables. Okay. So why do I need a temporary table? When it comes to this is called physical table. It will be, the structure will be created physically. It will be stored physically in your database. Right? Let's say I am going to perform some operation. During that process, I need to hold some data temporarily until that process is completed. Once that process gets completed, now that has to be destroyed. Can I destroy my permanent table every time? No, you will lose the original structure, original data. You cannot do that. But here I have a requirement like I need to hold some data temporarily in some table during my process. Once the process gets completed, then it has to be destroyed. Then you'll go for a concept called temporary tables. Whenever you need to hold your data temporarily, this can be done in 4 different ways. First thing is table variable. Next thing is CTE, common table expression. Next, local temp tables. Next, global temp tables. Whenever you need to hold your data temporarily during some process inside stored procedure or view, wherever you need to hold some data temporarily during some process, then your approach should be towards temporary tables. This can be held in 4 different ways. The first one is table variable. Second one is CTE. Okay. And let's keep it that way. CTE and table variable. Let's go one by one. First, let's go with CTE. Common table expression. When it comes to CTE, you can hold your data something like this. For example, we are doing some process. I'd like to hold some data temporarily during that process. How do I do this? You have to create a common table expression. How do I create it? Use UTA keyword card with CTE. You can give any name. I'm just giving it as called CTE. You can give any name. As this is the syntax. Now, within this, you can write anything. Whatever is being pulled within this block, that data will be held temporarily. For example, select employee ID, comma, EMP name from employee. Now what happens? Inside this, I'm extracting employee name from employee. So whatever is specified here, that data. So what happens now? Immediately it will create a temporary object with the name CTE, and whatever is being pulled, that will be kept inside the temporary object, and this object will be holding till your process is running. Once that context gets closed, it will be destroyed automatically. You don't have to dispose it explicitly. And here what I'm doing, I'm creating a temporary object and keeping this data inside that temporary object. Now, wherever I need it within my process, I can access it. If I say select star from CTE, what happens? Now this has been stored into CTE. Now I can directly select data from CTE. Let's see this. See, it is working. Select star from CTE. Now I got my data. This is called common table expression. Wherever you need to hold some data temporarily, then you can go with the common table expression. The advantage of CTE is it doesn't require many resources. It requires minimal number of resources. If you hold anything using CTE, you don't have to dispose it explicitly. It will be destroyed automatically. For example, this is my whole process. First, like this data will be kept into this your CTE. One temporary object will be created. This data will be placed in the temporary object. Once my process gets closed, the CTE will be destroyed automatically from your process, from your main memory. This is a kind of in-memory object, right? Whenever I say with CTE as, here inside this, you can write any query, any operation, any calculation, right? So whatever is extracted, it will be kept inside this temporary object. Now this temporary object, your CTE can be used anywhere in any process. This will be existing till your process is alive. Once this process gets finished, you can create a number of CTEs, not only one CTE. All your CTEs will be disposed automatically. That is one of the good advantage of CTE. But there is one disadvantage. What is that? I can hold my data temporarily. If this is going to have 2 or 3 records, fine. If I'm holding some thousands of records, again, your CTE is going to be used in further process. Here, if I need to find something in CTE, right? It should have a valid index. It should have a valid data type. Read me. So, but that is not supported through your CTE. For example, let's say your CTE is holding some millions of records. I'm using this in some process. If I'm searching for something, what happens? It will definitely degrade performance of your application because it doesn't contain any data type. It doesn't contain any index. And I want to give some serial numbers to this, like your identity column. Read me. I would like to arrange whatever is extracted. I would like to arrange them using some sequence numbers. That way, at least I'll be able to speed up my process. That is not possible, right? So here you cannot specify. So whatever is being held inside this, you cannot specify the type of this, you cannot define a proper structure and hold them. Whatever is extracted, you can just hold them as is, but you cannot hold them using a proper structure like your table. That is one of the disadvantage of CTE. But the advantage is it will be destroyed automatically. If you want to hold it within the process, if you want to hold it using a proper table structure, then your approach should be towards table variable. Table variable. Whenever you need to hold some data using a proper table structure within your process, during some process, then your approach should be towards another temporary variable called table variable. Any questions, guys?
No, sir.
Okay. Now, how do I hold it using table variable? So table variable is a variable. It's like normal variable, like a int. Means we are declaring a variable called a. You are used to use, if you are declaring any variables inside your stored procedure, you would use a keyword called declare. Declare is the a int. So we are defining a variable of type int. Your table can also be defined as a variable. We have a special data type like your integer, float, character. We have a special data type called table. How do I do that? Here I can declare something this variable. Let's say @tbl emp. You can give any name as int, as char, as float. Here I can define it as table. I can define the structure of this table. Let's say emp id int. Next, emp name varchar of 100, and I can also add identity column. If you want to give some serial numbers, int id identity of 1,1. ID int identity of 1,1. Are you with me? So I'm declaring a variable of type table and defining the structure, whatever the data to be held during your process, and based on your requirement, define your table variable with only those many fields. Now I can hold my data using a proper table structure. How do I hold it? Insert into your table variable. What has to be inserted? EMP ID, next EMP name, right? Select EMP ID, comma, EMP name from employee. Are you with me? Okay, now I'm inserting my data into this temporary table. Okay, insert into this. From where it has to be inserted from here. Okay, now what happens? Now, whatever is there in employee, I'm holding the data into my temporary table variable. Now I don't need to interact with employee. I can directly select my data from table variable. Select star from with the rate people EMP. Run this. See, I'm able to select my data. So what happened? We declared a table. Data got inserted from employee to your temporary table. Now, when I say select star from my temporary table, see, I'm able to see my data. I'm able to see my data, right? Now, what I'm doing in the previous case, there was no proper structure. When I use CTE, I can hold my data temporarily, but I cannot hold it using table structure. If you want to hold something using proper table structure, and if you want to give some automated values, sequence numbers to each and every row, then your approach should be towards table variable. When it comes to table variable, it is also like CTE, but the difference is here you can define a proper table structure. You can also have an identity column, and you can hold your data using this table variable. And the best part of this is you can define a proper structure. You can hold your data using proper structure, And once this process gets completed, even table variable will also be destroyed automatically. You don't have to dispose it explicitly. That is the difference between CTE and table variable. In this case, why do you need CTE? We can go with table variable, right? So everyone is having its own unique purpose. For example, we have seen views and stored procedures, right? When you talk about view doesn't allow any temporary tables. You cannot create temporary tables inside the view. But how do I hold my data temporarily? If I want to do some process inside the view, how do I hold it temporarily? So only CTE is allowed inside the view. Inside SP, you can hold your data using any temporary table. Everything is allowed. CTE is allowed. Everything is allowed. But views doesn't support temporary tables concept. But still, I need to hold some data. How do I do that? I can hold it using common table expression. Whenever you need to hold some data temporarily inside the view, you can do that through only CTE. Except CTE, no other temp tables are allowed inside. Any questions, guys?
No, sir.
Okay. So this is something about table variable. Advantage is you can hold your data using a proper table structure, and whatever is hold, so that will be destroyed automatically as soon as the process gets completed. But there is one more disadvantage. What is that? Let's say we are holding millions of records using this table variable. If I want to speed up the search process, what has to be done? If you take a general table, whenever you need to speed up search process, what has to be done? Some index has to be created on that respective field. Some index has to be created on that respective field, right? So when it comes to table variable, it doesn't support index creation. For example, during this process, I need to search some data using employee ID. Now it has no index. If there is no index on your table, what happens? It will definitely degrade performance of your search process. Are you with me? So when it comes to table variable, it doesn't support any index creation. You cannot create index on these. Are you with me? So you cannot create index on this. So if you want to hold your data using proper table structure, and if you want to have some indexes on your table, then your approach should be towards local or global temp tables. Local or global temp tables. Are you following me, guys? The disadvantage is you cannot create indexes on any column. If you're having the requirement of index, here what is my requirement? I need to hold my data temporarily using proper table structure. I need to have some indexes on specific columns. Indexing is not supported through your table variable, then your approach should be towards another concept called local temp tables, global temp tables. What is the scope of CTE and table variable? Within the process, the lifetime is limited up to process level. Once the process gets completed, CTE and table variable will be disposed automatically. You don't have to dispose it explicitly. But when it comes to local and global temp table, these tables will be created physically in the system database. In the beginning, we were talking about some system databases, right? Here we have a database called TempDB. Here we have created temporary tables. So these tables will be stored physically in your TempDB. And once your process gets completed, this table will not be destroyed automatically. It has to be destroyed explicitly by the program. Are you with me? So what is the difference between local temp and global temp? Local temp will be available to within your process. Let's say if some local temp table is created inside the stored procedure, that will be available to only that. What is a global? Other process can also access your temporary table. Other process can also, that will be available to all sessions and all other processes. Okay. How do I create it? It is very simple. Select star into, give the name local temp starts with single hash and global starts with double hash. If the table name is started with single hash, it will be treated as local temporary table. If the table name is started with double hash, it will be treated as global temp table. What is the difference between these two? The scope will be differed. That is only the scope of this is going to be local. The scope of this is going to be global. That is only the difference. But except that everything is same. Has some team EMP1 from. We are saying that hey, select data into this temporary table from which table? Employee. Now what it will do? It will create a temporary table with the name temp EMP1. Select data from employee and keeps into this. So what it does, based on this employee structure, whatever is there in employee, it will create a similar structure of employee and give the name as temp EMP1. And this will be stored and this will be stored in this. What is the scope of this? If I close my SQL server and reopen it, this will be dropped. This table will be available to only that particular session. What is the scope of this table? Whenever I open my SQL server, right? Let me show you. Okay. Select star into temp EMP1. Select star into temp EMP1 from employee. Now what happens? It will create one more table with the similar structure of employee and give the name as temp EMP1. Where it will be stored? It will be stored in your temporary tables. Let's see that. Now I can say select star from my temporary table. What is that? Right? Let's go and refresh it. See, it got stored. Right? Now, each window, each query window would represent one session. Now I'm going to next query window. What happens? Invalid object name. Because this is one session and this is another session. As I said, what is the scope of this? Within this session, you can access it a number of times. See, this is my session. And I opened another query window. It will represent another user, another session. From here, it is not accessible. Though it is stored physically here. That is the scope of your local temporary table. Let's create a global one. Temp2. It will also be stored here. See, here I can access it. Did you understand the difference? Okay, so the local temp table scope is limited up to the same session. Within the same session, you can access it n number of times. If this session gets closed, now you can see two tables. If this session gets closed, let's say I'm destroying it. What happened? All table got dropped automatically. But if this session is alive, till the session is alive, nothing will be dropped. You have to drop it explicitly. That is the difference between local temp and global temp. And when it comes to temporary table, you could also define the structure, something like this. Create table hash temp1 ID int identity of 1,1. And as I said, it also supports indexes. You can create primary key, you can add indexes, you can add clustered index, you can add non-clustered index. So the structure of this, the behavior of your temporary table is very similar to your normal table. The only thing is the scope is limited. Once your session gets closed, all temporary tables will be destroyed automatically. If you want to perform multiple operations within the same session, then it has to be dropped explicitly from your session. Any questions, guys? Any
No, sir.
questions? This is
No.
very important. Many interviews will ask this question, and we'll be using these local and. Okay. Once again, I repeat this. Whenever you need to hold some data temporarily during your process, your approach should be towards any one of these four. But you have to decide what is really required to accommodate my requirement. If no structure is required, if you're going to hold some piece of data, small amount of data, where the structure of table is really not required, you can use CTE. If you want to hold some data temporarily inside the view, only CTE is allowed. If you want to hold some data temporarily using proper table structure, then go with table variable. You don't have to despise these two explicitly. Once the process gets completed, this will be displayed immediately. Here you need to understand the concept of process and session. A session memory and a process memory. For every user, one thread will be created and some amount of memory will be allocated. That is called session. For every user, one separate session will be created. All your requests will be served within that session. For every session, some memory will be allocated. That is called session memory. And all your requests will be served within that memory. And within a single session, you can run n number of processes. Again, every process will maintain its own memory. So the scope of CTE and table variable is up to process level. Within a session, you can have n number of process. Process 1, process 2, process 3. If CTE is created in process 1, the scope is up to process 1. Process 2 cannot hit process 1. Once process 1 gets closed, your CTE and table variable will be destroyed. Okay. If you want to hold data temporarily, and if the scope has to be extended up to session level, I mean, within a session, n number of process will be there. If any temporary data has to be used by more than one process within the same session, then you have to keep your data in local temp. If the data has to be available to multiple sessions within the same database server, use global temp. What is the difference between table variable and this? Here also you can define the table structure. Here also you can define the table structure. But the difference is table variables doesn't support indexing. Here it supports indexing. You could also have proper indexing on your table. Any questions, guys?
No,
Great.
sir.
Okay, so we completed the SQL Server concepts. From tomorrow, we will start implementing GUI-based application. First 2 to 3 days, it is going to be Windows-based application where we will play with all Windows controls. And from Windows, you will connect to database. And again, you will see all these things like your table, stored procedure, queries, and everything over there. Then we will move on to web. Okay.
Okay.
Okay, guys, we will meet tomorrow.
Thank you.